Next up, we have Tomas Ruiz from Witnet, who will be speaking about how to overcome the challenges of developing a truly multi-chain Oracle network. Tomas, everyone.
Okay, good afternoon, everyone. I hope everyone is enjoying this wonderful conference. And my name is Tomas Ruiz, and I'm the tech lead in Witnet. Today, I'm going to tell you, you will see the different challenges that we have building a decentralized Oracle network, and also what we have gone through trying to deploy the Witnet contracts and the Witnet chain into the different chains that we are live right now. And then also we will see an example of how we try to solve those problems to make things easier for us. To give some brief context, Witnet is a multi-chain decentralized Oracle. We are a layer 1 that we have to build from scratch. And it's with Witnet, you can query any public API. So the data request creator can define with a domain-specific language that we have created, can define the different sources, can choose these sources, define how do you want to aggregate them, and finally how to kick out the outliers. And it's a highly parametric data request. Right now, we are live in 26 different networks. I have just seen a PR, and I think we are live in 27 right now. But yeah, we have gone through a lot of different challenges or problems trying to integrate. I have a huge disclaimer here. I'm going to say the names of different chains, different networks. That doesn't mean that these networks are better or worse in any aspect. We made a first integration with Ethereum, so what was easier for them was to go in EVM networks, and the ones that are more EVM compatible, they were easier for us, but it doesn't mean that they are better or worse. So the first thing that we face, or the first problem that we see when we were trying to integrate the first network that was not Ethereum, was that a lot of different networks were pushing us to deploy on their chain, and they were saying, hey, integrate this network. A network is super easy. It's straightforward if you already have an integration with Ethereum because we are EVM compatible. And the first thing that we realized is that Ethereum is not the same as the Ethereum network is not the same that that EVM compatible. So basically, when some protocol or when some chain tells you that a network is EVM compatible, it only means and only guarantees the compatibility between Ethereum, the Ethereum virtual machine. So your smart contracts are going to work, but maybe the ecosystem is going to be completely different, and MetaMask is not going to work, or your Web3 library is not going to work either. So the second problem that we face, or the second thing that we see, was that for some networks, they have different native tokens. For instance, in the case of Cello, which is a layer 1, they have 3 different native tokens, which are stable coins, which are pegged to the euro, the USD, and also the Brazilian real. So we had our transaction with some shape in the way that you are interacting with Ethereum. All the things were equal, and we had to adapt some things to being able to send or to use Cello, because the transaction format in Cello, it depends or changes according to the token that you are using to pay the gas. So we have to build something that we will see later to being able to consume those, to be used or to use that chain. And also this was a bit easier in the case of BOBA. BOBA is a roll-up layer 2, and they have 2 different native tokens. The first one is the BOBA token, and also the token of the network, the base layer. And first you need to send a transaction defining or signaling which is the token that you want to use for paying the gas. Then there was something also related to the gas, in this case, the gas limit on some layer 2s. We experienced that in the networks that are a fork of Optimism, for instance, BOBA or Optimism itself, when you are on a layer 1, the gas limit is a constant thing according to the type of transaction that you are sending. So every time that you are going to call to get the gas limit, you are going to call a provider, you are going to get the same result. But when you are in some of these layer 2s, you are going to experience that some gas limit will vary according of the cost of running that layer 2. And you could even have something that is not measured in gas units, it's measured in something different because they decide to grab this. This was, or as far as I know, this is how it's right now on BOBA. In Optimism, they made some changes, and every network has adapted this to fit their needs. Also, a huge different kind of networks. If you are familiar with Substrate, Substrate is a software development kit that allows you to create specialized chains, and you can use them to create EVM-compatible networks. The most common use case for this network is the Polkadot under Substrate ecosystem, and they were created using Substrate. So you can also create an EVM compatible with one of their modules. Their modules are called palettes, and you can consume those palettes to compose an EVM compatible network. But the main problem with that is that some chains that are going to use Substrate, they are going to say that they are EVM compatible, but all the ecosystem that they have is not compatible at all with all the tooling that we are used to use in Ethereum or the most common EVM compatible chains. So we were lurking in their documentation, and we saw that the Rift chain was based on Substrate, and we couldn't use MetaMask. We couldn't use the Web3 library. We could not use a normal wallet. We had to use their replacements. It was not difficult, but also the JSON-RPCs were not compatible at all, and it was a lot of work that we have to devote to integrate a Rift chain. So another thing that we found is that the JSON-RPCs are the way that we have to interact right now with a chain. And the main problem that we saw is the lack of uniformity in the JSON-RPC providers. We even found some interesting JSON-RPC providers that they decide to give their service or expose their service as a GraphQL endpoint, which is not common at all. And we had to adapt all the methods that we had or we were calling to interact with a JSON-RPC to being able to call a GraphQL endpoint. Also, something funny that we have found in a lot of different JSON-RPC providers is that they suddenly stop working. We trust or we use quite reliable JSON-RPC providers for Ethereum, for the bigger chains, but some networks or some chains that are starting to work, they could have that problem of faulty JSON-RPC providers, or suddenly, for any reason, you get banned, or you achieve some rate limit, or something that we have found in a lot of different chains is that some methods that they should be available or apparently they exist in Ethereum or we have been using in some integrations, suddenly in one chain for any reason that they had, they are not supporting that method in the case of the Ethereum sync status. So also, when we are integrating a new chain, we have to take into account that every network has their own specific nuances. So every network is going to have their specific gas limit. They are going to have a different finality. You will need to take that into account for any business logic that you would like to implement, or you will have to expect to have a different tooling. The ecosystem tooling could be completely different. And the layer 2s also could rewrite or overgrab the methods, and you are calling one method in one layer 1, then you call that layer 2, and you are going to have a different behavior just because they decided to change it. So to make things easier for us and to being able to call all the different methods as the way that we were doing it in Ethereum, we created a JSON-RPC gateway. The name is a bit wordy, but we are open for new names. Basically, this JSON-RPC gateway, what does is to grab the JSON-RPC calls. It grabs the provider in a clear and manageable way. So you can handle accounts and you can delegate the calls to the third-party providers. And the most important thing for us was if we have a tab or if we have a service where we are deploying contracts from there, we don't want to have that service exposed to the public. We prefer to have that in a private service, in an internal network, and we access that to a public endpoint, but we don't have any key or anything sensible. We don't have that exposed. So, but for this case, the main benefit of using this JSON-RPC gateway is that allow us to call all the different chains that we are integrating in the same way that we will be calling any EVM network. So if we were using or if we were calling one of the methods that I told that they were not available on a network, we will be able to call them. Could handle that error, but we will be able to achieve that. So it works in a really easy way. We have an app, a user, someone who wants to interact with a JSON-RPC. And there's a middleware that in this case is going to be our JSON-RPC gateway. And you will have to specify the provider that you want to use under the hood. You could use Infura, Artemi, any provider, or you could even call a node that you are running. And you will call it in the same way that you are going to call Ethereum, and then this middleware is going to format the transaction to handle the parameters to be exactly the same that Ethereum will be expecting. They will transform them into the way that the specific network needs, and also it will grab and normalize the result to give you what you were expecting. So this was an easy thing to do for some networks. For instance, when we made an implementation for Conflux, we were able to find almost one method for every Ethereum method. And basically, we just need to create a dictionary. And that dictionary, when we are calling the Conflux network, we are just grabbing and using that dictionary. So we have a one-to-one relation. But there were other networks, like the case of Riff, where those methods, they didn't have the same name. Even they didn't have a similar name. The parameters were completely different. The units that they were expecting, their inputs were completely different. They have even a different address format, and we had to make different conversions, and we have to overgrab all the different methods to make it compatible with a JSON-RPC gateway that is common in Ethereum. So the way to use it is quite simple. You can just download it or use it as an npm package in your project, and or you can just clone the repository on GitHub. You just need to specify some environment variables. For instance, you have to specify the port if you want to run it as a server, the network in the case of. For instance, if you want to use Rinkeby or Robsten or any network, the seed phrase if you want the gateway to handle the accounting for you, and the provider that you are going to use. And as every network has its own nuances, every network needs some specific parameters. For instance, we have a lot of different configurations and a lot of different environment variables that we have defined, and you can pass. And the gateway is expecting to handle some methods, to remove some methods, to ignore others. And as this could be a quite challenging, or we have gone through a lot of different networks, we know which environment variables we have to pass. So we have created an npm script for each one of the different networks that we have. So if you want to use this and take profit of our work, you can just consume it as they are, or if you have any specific business logic that will modify how you are consuming it, or you don't want to have a specific assumption that like we are having for some providers, you can just override them. So the main takeaways that we can extract from all the work that we have devoted to implement or deploy contracts in a lot of different networks is that EVM compatible means, it doesn't mean what most people think about, which is, okay, EVM compatible means that all the ecosystem is compatible, that all the different things of that ecosystem are going to work. So there are a lot of different Ethereum flavors or Ethereum compatibility flavors. So you will have, if you are integrating a network that is EVM compatible, you could struggle. Or it could be, if they are just a fork of Ethereum, it will be much easier. So the only thing that you can guarantee when you are integrating an EVM-compatible network is that the contracts are going to work and the EVM opcodes are going to work. And basically, we built the Web3 JSON-RPC gateway for two reasons. The first one was to achieve uniformity between the different networks that we were deploying. And also, we wanted to isolate and have in a private network our service that was handling our accounts. And I think I'm right on time. And there are some times for questions. And thank you, everyone. If I don't use too much Twitter, but if you want, you can follow me or send me a direct message. Thank you.